We're going to begin our journey into two-dimensional figures by naming and classifying polygons. Now, what we mean by naming is just simply identifying the number of sides in a polygon. And when it comes to classification, we got two things we're going to consider. One, is it convex or concave? And the definition of really between whether it's convex or concave, if you were to extend the lines of the polygon, would any of those lines go into the interior of the polygon? But another way that I like to think about it is concave. Does it cave in on itself? And if it's concave, convex, concave. And then lastly, whether it is regular or irregular. Now, for a polygon to be regular, it's got to be convex. So only convex, not concave. Concave polygons, by definition, are not regular. And even if it's a convex polygon, it must be both equilateral and equiangular. So let's look at what we have here first. Well, here on the left, I can see that pretty easily that it's got four sides. So it is a quadrilateral. Next, is it concave or convex? Well, I don't see it caving in on itself. And in fact, if I were to extend these lines, let's say like this, I can see that none of those lines would go into the interior, so it's convex. Now, since it's convex, is it regular or irregular? Well, it is equiangular. All of the angles are 90 degrees, but for it to be regular, it's got to be both equiangular and equilateral. In other words, the measures of the sides have to be the same. And here I see that these two are congruent, but here we have the measurements, they're congruent, but they are of a different measure. So this is also irregular. All right, let's look at this next example. How many sides? I might better count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 sides, so it is a decagon. Might think of decimal. Decagon, 10, deca, 10. Is it convex or concave? Well, I can just by visual inspection see that it is kind of caving in on itself. But if I were just to extend, let's just say just this line. If I were to extend this line out, well, I've got points on that line that would be on the interior, which would further tell me that it is concave. And by definition, when I'm thinking whether it's regular or irregular, if it's concave, it must be irregular. All right, let's look at one other example in naming and classifying polygons. All right, so here I have another polygon. Let's count the sides. 1, 2, 3, 4, 5, 6. So it's six-sided, so it must be a hexagon. Hexagon, six-sided. Triangles, 3 sides. Quadrilaterals, 4. Pentagon is 5. Hexagon is 6. Heptagon is 7. Octagon is 8. Nonagon is 9. Decagon is 10. Hendecagon is 11. Dodecagon is 12. Okay, just give you a few of examples. So it's a hexagon. Is it concave or is it convex? And again, if I extended all the lines out, and I'm not going to do them all, but if I were to just extend these lines, I'm not going to have any point on a line that is in the interior of the object, so it is convex. Now, is it regular or irregular? Well, I can see by these little angle markings, it is equiangular. And then when I look at the sides, they're all congruent, so they are It's also equilateral, so it's convex and it's both equilateral and equiangular, and so it is a regular polygon. Isn't this fun? So much fun I can't stand it.